ComfyUI is the AI creation engine for visual professionals who demand control over every model, every parameter, and every output. Its powerful and modular node graph interface empowers creatives to generate images, videos, 3D models, audio, and more. ComfyUI natively supports the latest open-source state-of-the-art models. API nodes provide access to the best class at source models such as Nano Banana, Seedance, Unicorn 3D, and others. It is available on Windows, Linux, and Mac OS, locally with our desktop application, our portable install, or on our cloud. The most sophisticated workflows can be exposed through a simple UI thanks to App Mode. It integrates seamlessly into production pipelines with our API endpoints. Get started. Locally, the easiest way is the desktop application available on Windows and Mac OS. For Windows users who want a portable version that runs on NVIDIA GPUs or on CPU only, there is a portable standalone build. Simply download the zip, extract it, and run the executable. For other operating systems and GPU types, such as AMD, Intel, Apple Silicon, or Ascend NPUs, follow the respective installation instructions in the documentation. For example, on Linux with an AMD GPU, you can install PyTorch with ROCm using pip and then run the main program. On Windows with an NVIDIA GPU, you install the stable PyTorch with a CUDA 13.0 index URL and then start ComfyUI. The installation tips cover troubleshooting such as uninstalling and reinstalling PyTorch if you see a torch not compiled with CUDA-enabled error. Several convenience options exist. ComfyUI is also available as a cloud version called Comfy Cloud, our official paid cloud service for users who cannot afford local hardware. For devs and power users, there is a ComfyUI Manager extension that allows you to install, update, and manage custom nodes easily. It is installed via pip, enabled with a flag when running the main program, and offers a legacy UI if you prefer older interfaces. Features include a visual node graph for building and reusing workflows without code, reusable subgraphs, workflow templates, app mode, and a local API. Intelligent Execution manages VRAM and RAM usage, supports partial re-execution, and can offload models. It supports a wide range of models, image generation models like Stable Diffusion 1.5, SDXL, Flux, and many others, image editing models such as Flux Context and HDream, video generation models including 1.2.1, LTX Video, and Kandinsky 5 Video, audio and video generation with Minimax H3, audio generation with ACE Step 1.5 and Stable Audio, 3D and vision models like Unicorn 3D, Tripo Splat, and SAM, and text generation models such as Gemma 3 and Quant Series. ComfyUI can load complete checkpoints or separate diffusion models, Vs, text encoders, LoRa's, control nets, adapters, and upscalers from supported formats. It comes with built-in tools for inpainting, outpainting, reference conditioning, masks, compositing, model merging, upscaling, frame interpolation, segmentation, depth estimation, and media processing. Workflows can be saved and loaded as JSON, and you can recover complete workflows and seeds from generated media. The core does not download anything unless you request it, so it can run fully offline. If you want to keep all functionality offline, use the flag to disable the optional paid Comfy API nodes. Custom nodes can be added, and you can configure additional model locations by editing the extra model paths YAML file. ComfyUI follows a weekly release cycle that targets Monday but changes with model releases or major code changes. There are 3 connected repositories. The core repository releases a new major version every 2 weeks. The desktop repository builds a new release using the latest core version, and the front-end repository merges updates every 2 weeks. Features are frozen for the upcoming core release, and development continues for the next cycle. Keyboard shortcuts in the editor include using Ctrl-Enter to queue the current graph for generation, Ctrl-Shift-Enter to queue it as first, Ctrl-Alt-Enter to cancel, Ctrl-Z and Ctrl-Y for undo and redo, Ctrl-S to save, Ctrl-O to load, Ctrl-A to select all, Alt-C to collapse or uncollapse nodes, Ctrl-M to mute or unmute, and Ctrl-B to bypass a node. Deleting nodes uses delete or backspace. Ctrl-Backspace deletes the whole graph. Space lets you pan the canvas. Ctrl or Shift plus click adds nodes to the selection. Ctrl-C and Ctrl-V copy and paste, with variations that maintain or ignore connections. Shift-drag moves multiple nodes simultaneously. Alt plus and Alt, zoom in and out. Ctrl-Shift-LMB plus vertical drag also zooms. Press P to pin or unpin selected nodes. Ctrl-G groups nodes. The Q key toggles the queue visibility, H toggles history, R refreshes the graph, F shows or hides the menu, and the period key fits the view to the selection. Double-clicking the left mouse button opens a quick search palette for nodes. Shift-drag also moves multiple wires at once. Ctrl-Alt-LMB disconnects all wires from a clicked slot. On Mac OS, CMD can replace Control. Installation steps vary by platform. On Windows, the desktop application is the recommended method. For a portable build, download the .7z archive, extract it, and run the executable. Place checkpoints in the Models Checkpoints folder and add any other assets to the appropriate subfolders. Ensure your NVIDIA drivers are up to date if using the portable build. For Linux and Mac OS, clone the repository, install Python 3.13 or later, install the required packages from requirements.txt, and copy your SD checkpoints, LoRa's, and other assets into the Models folder structure. On Linux with AMD GPUs, install ROCm and PyTorch with the appropriate pip command. For Intel Arc GPUs, install PyTorch with XPU support. For NVIDIA GPUs, install the stable PyTorch with the CUDA 13.0 index or the nightly CUDA 12.6 version for older GPUs. Apple Silicon users install the latest PyTorch nightly, then follow the manual installation steps. For Ascend NPUs, Cambrican MLUs, or Iluvador Corex, the documentation provides specific steps for installing the necessary drivers and PyTorch extensions. Once dependencies are installed, run Python mainpy to launch the application. If you want to use TLS or SSL, generate a self-signed certificate and key and launch with a TLS key file and TLS cert file flags, which will make the app accessible over HTTPS. ComfyUI also offers a high-quality preview method. By default, it gives a fast, LoRa solution preview, but you can enable high-quality previews using the TAESD decoder packages. Download the decoder files, place them in the Models via prox folder, restart the program, and launch with a preview method test flag. If you run into issues, the documentation provides troubleshooting sections for different hardware. For example, if you receive the torch not compiled with CUDA-enabled error, uninstall torch and reinstall it with the appropriate pip command for your GPU. For AMD cards not officially supported by ROCm, you can override the graphics version with environment variables before launching. ComfyUI is also open for community contributions. The Manager extension allows you to install custom nodes and keep them up to date. The frontend is hosted in a separate repository and updated frequently. You can switch between the default frontend or a nightly release by passing the front-end version flag with a desired commit or tag. In summary, ComfyUI gives creators complete control over advanced AI workflows, supports a wide array of models across images, videos, 3D, audio, and text, runs locally or in the cloud, and is highly configurable with a rich set of features and shortcuts. Its modular node graph, efficient execution, and extensibility make it a powerful tool for both hobbyists and professionals.